Have you ever been watching a big sports championship and just found your mind wandering to the numbers behind it all? The what ifs and the probabilities? Well, today we're diving into a really cool probability puzzle that comes straight from the World Series, using a great problem from Beestar.org to show how a seemingly simple question can have a really surprising answer. Okay, so let's set the stage. Picture this. It's the World Series of baseball. It's a best-of-7 series, meaning two of the best teams are battling it out, and the very first team to get to 4 wins gets to call themselves the champion. So here's the big question we're tackling. What's the actual probability that one team just completely dominates and the whole series is over in just 4 games? A perfect sweep. Before we break it down, just take a second. What does your gut say? All right, before we start crunching numbers, we have to lay down some ground rules for our little thought experiment. First, we're going to assume both teams are perfectly matched, equal skill. That means for any given game, it's basically a coin flip, a 50-50 shot for either team to win. And, of course, first to 4 wins takes it all. Pretty straightforward, right? Now, with probability puzzles like this, there is almost always a trap. A really tempting, common-sense answer that feels so logical, so right, but it misses one tiny, crucial detail. Let's walk right into that trap together and see what it looks like. So, how would you even start to solve this? I think a pretty logical first step would be to just pick one of the teams, let's call them Team A, and try to figure out their specific odds of pulling off this incredible sweep. For Team A to get that perfect sweep, a whole bunch of things have to go exactly right, back to back. They've got to win Game 1, that's a 1 in 2 chance. Then they have to turn around and win Game 2, another 1 in 2 chance. Same thing for Game 3, and then finally, they have to win Game 4. Each step is its own little coin flip. Now, to find the probability of all 4 of those things happening one after the other, you just multiply their odds together. So you take 1/2 times 1/2 times 1/2 times 1/2. And that calculation gives you 1/16. Now, that feels like a pretty solid answer, doesn't it? A 1 in 16 shot for a team to win 4 straight. Seems reasonable. But here's the thing. If this were a quiz, you would have just walked right into the trap. And this brings us to the key insight. This is that aha moment, the pivot point where the whole problem kind of flips on its head and the real and honestly more elegant solution starts to come into focus. But wait a minute. Is that calculation really telling us the whole story? You know, the absolute most important step in solving any problem is making sure you're answering the right question. So, are we? Check out this quote from our source, Beestar.org, because this single sentence is the key that unlocks the whole puzzle. It says, "The first game does not matter because it has a winner anyway." Just let that sink in for a second. This right here is the heart of the matter. Our 1/16th calculation was the correct answer to the question, what's the chance of one specific team sweeping? But the real puzzle, the one we were asked, is what's the chance of a sweep happening at all by either team? They sound almost the same, but in the world of probability, they are worlds apart. Okay, so now that we're armed with that key insight, let's rebuild this thing from the ground up and find the actual winning probability. So here's the big idea. Game 1 is basically irrelevant to our calculation. I mean, someone has to win it, right? The game is guaranteed to have a winner. All Game 1 really does is act like a signpost. It points to one of the teams and says, okay, a sweep is now officially possible for this team. Let's see if they can finish the job. So after Game 1 is over, our real probability question begins. The only thing that matters now is if that winning team can keep the streak alive. So for them to also win Game 2, the probability is a simple 1/2. And for them to keep that incredible momentum going and take Game 3 as well, the odds are, you guessed it, 1/2 again. And finally, to close it out, to complete that perfect sweep with the 4th victory, it all comes down to one last coin flip to seal the deal. A 1 in 2 chance. So you see, the real calculation is actually much shorter. We don't care about 4 coin flips. We only care about the 3 that have to happen in a row after the first game is decided. So it's just 1/2 times 1/2 times 1/2, which gives us our true answer, 1/8. The probability that the World Series ends in a 4-game sweep isn't 1 in 16. It's 1 in 8. It's actually twice as likely as that first tempting answer we came up with. So, yeah, it's a fun little brain teaser, but why does this really matter? Well, because this whole thought process, this way of thinking, it applies to so much more than just baseball or sports. It's really all about being precise and spotting hidden assumptions. The big takeaways here are pretty universal. First, you've always got to define your question with absolute precision. We saw how just changing the words from one specific team to either team completely changed the answer. It also shows how our so-called common sense can be a real trap when you're dealing with probability. How a question is framed is quite literally everything.
And all this leaves us with one final thought to chew on. We figured out that a quick 4-game sweep has a 1 in 8 chance of happening. So, what do you think the probability is that the series goes the other way, all the way to the maximum distance, a dramatic winner-take-all Game 7? It's a fun follow-up to think about. Thanks so much for diving into this with me.